Hello, this is question 3 from exercise 10F of the Edexcel textbook Statistics and Mechanics. So here's our question, and it's really important to start with a diagram. So here's my pulley, and I have hanging from this 2 particles, and this is particle A, and this is particle B. So 2 particles, and just to start with saying that, I'm going to draw in the surface. 2 particles A and B have mass m and 3 kilograms. So for A, and I'll draw this on a different colour, this is going to be mg is the force, which is its weight acting downwards, and acting upwards in the string is tension. I'm just going to put a dotted line over there because it's going to help me in a moment when I think about it separately. And this side I have B, and the weight, which is the force acting downwards, would be 3g here, and acting upwards is tension. Because this is a light inextensible string, and because the pulley is smooth, the tension is constant throughout that light inextensible string. It's really important to remember that. So the value for T here is equivalent to the value for T here. Now there is a really other important piece of information in here, which is here, where m is greater than 3. So m, which is the mass of A, is greater than 3. They've told us that for a reason. And what it means is here, if this is greater than 3, it means the weight here, pulling it down, and that's your force, is greater than the weight here, the force pulling B down. So therefore, when this system starts moving, it's going to move this way because the mass is heavier this way. And when we solve one of these questions, it's very, very important to actually think about which direction it's moving in. So we're moving down on the A side, and we'd be moving upwards on this side. So that is the direction of motion. So when we start one of these questions, you need to make sure that you think about which direction the system is moving, and you must mark on the direction of motion. You must mark on your tensions, and you must mark on the forces, which are the weights acting down. Now, let's go through and see if there's any other information that we need to put on our diagram. And we've said the particle connected by a light inextensible string which passes over a smooth fixed pulley. Initially, A is 2.5 meters above the horizontal ground. So I know that it says A is 2.5 meters, so this distance here is 2.5 meters. The particles are released from rest, so that tells me something. So U equals 0. it says initially A, we've already read that bit, but let's just go here. So the particles released from rest with the string taut and the hanging parts of the string vertically as shown in the figure. After A has been descending for 1.25 seconds, so I have a T equals 1.25 seconds. So what happens at that point? It strikes the ground. So if it strikes the ground, we know it's moving in this direction because we've said that this force acting down is greater. So we know that A has travelled 2.5 metres. So S equals 2.5. Particle A reaches the ground before B has reached the pulley. So what it's saying is this distance here is less than this distance up here. Show the acceleration as it ascends is 3.2 metres per second. So now I'm going to need to use one of my Suvat equations. I know that I need A because I want to find out what A is. And I also know that I've got U, T and S. So I'm going to use S equals UT plus half AT squared. So S is 2.5. UT, so U is 0 times T, so that would be 0 plus a half multiplied by A, which is what I want to find, multiplied by T squared. Typing that into my calculator now, I'll get 2.5 equals 0.78125 A. Therefore, A equals, again just using my calculator, 3.2 metres per second to the minus 2. So there's my acceleration, which we were told the value in the question, which is helpful, particularly if you get stuck on that part. You can always jump in at part 2. So that's part A solved. Part B. Now part B is all about using F equals MA, because this is about when you apply a force that you're going to get acceleration because it's moving. The forces are not in equilibrium, okay? Because if they're in equilibrium, they'll carry on travelling at a constant velocity, or if they're stationary, they will not move. So it's quite important. Force is in equilibrium. If the particle is stationary, it will remain stationary. If the particle is moving and the forces are in equilibrium, it will continue to move at the same velocity. So it will just carry on. Here we have acceleration, which means the forces can't be in equilibrium. So we are going to resolve separately for particle A and particle B. Okay, so we resolve separately. So first of all, for particle A, now I resolve in the direction of motion. And the direction of motion for particle A is down. Very important that the direction of motion is the direction you resolve in. And remember, everything that's now, the forces that are acting downwards are going to be positive. So if I look at particle A, and I'm just going to point to it so that you're clear where we're looking at. So we're just looking at this here, and we're looking at these forces. Then the forces acting down in the direction of motion are mg. The forces acting in the opposite direction, so against motion, is t, so it's subtract t. So mg acting down, so it's mg subtract t. And that must equal our mass, which we don't know, times our acceleration, which is going to be 3.2. Now, looking at that there, I'm going to look at that and go, well, there's nothing I can do. So I would now go and look at particle B. Now, some of you may have spotted, well, I'd go to particle B straight away, and that's brilliant. That's what you need to do. But if you don't know what to do, always start resolve for both particles. So if we go now to particle B, and we've got to think again, what way are we going to resolve? So what's the direction of motion? Well, the direction of motion is upwards this time. So notice now the force that's going to be positive, that's acting on the particle, is T. Subtract the forces that are in the opposite direction, which is in this case 3g. So that's my forces. And that must equal my mass, which is 3, times my acceleration, which is 3.2. So continuing from here, T would equal 3 multiplied by 3.2, add 3 multiplied by 9.8, because remember gravity is 9.8. So we type that in and we would get that tension is equal to 39 newtons. Now from here you can go on and start looking. It asks you how to find the mass of particle A. Well, if I look at having got this here, T 39 newtons, well, I can use this with tension and gravity to help me find the mass. And all by just resolving, I can actually work through solving lots of the question. I'll leave the rest for you to do. I hope you're successful. Thanks for listening.